So we're looking at the acidic nature of the carboxylic acids, and as the term suggests, they are acids, which means they are proton donors. However, they're only weak acids, which means that they only partially dissociate in water. So you can see here it's this bond here that is donating the proton, leaving us with what we call the carboxylate ion. So if we had ethanoic acid, we'd end up with ethanoate. If it was propanoic acid, we would end up with propanoate. Okay, so it donates its protons partially because it is a weak acid. Because it is a weak acid, or because it is an acid, it reacts in exactly the same way as all other acids. And for some reason, students find this really difficult to get their head around. So I'm just going to go on to here to try and get that idea around. I've got the carboxylic acid drawn and sodium hydroxide. And I hope you remember that an acid with a metal hydroxide makes salt plus water. And the water comes from the hydrogen from the acid and the hydroxide in the metal hydroxide. So here's the water over there, okay? Now, on the one underneath, what I've done is I've drawn hydrochloric acid the other way round. So instead of HCl, I've written it as ClH, so that you can see that the carboxylic acids behave in basically exactly the same way. That this section of the acid here is exactly the same as the chloride section in the acid there. So in exactly the same way, this is going to form water over here. What you're left with is the bits in blue, which in this example here is going to give you sodium chloride. And in the one above here, we're going to end up with sodium carboxylate. So it could be sodium ethanoate, sodium propanate. And the way we write this is RCOO. Na. Now, it's actually ionic at this point here because the carboxylate ion has a minus charge. The sodium from the sodium hydroxide has a positive charge. You don't have to write the charges in, and I'd actually prefer you not to write the charges in, because if you write one of the charges in and not the other, it's wrong. The one thing that you must not do when you're writing these out, if you do it displayed, is that you must never do that, because it is not a covalent bond, it is an ionic bond. So the best thing to do is to write it as RCOONA and get rid of those charges there because they cancel out. Okay, so exactly the same way as all of the others. So a metal and an acid gives salt and hydrogen, and again I've got sodium metal in there, reacting with hydrochloric acid and also with a carboxylic acid. Underneath that, I've got metal hydroxide with hydrochloric acid and also with a carboxylic acid, and that makes salt and water. That's the example that I used. And the one underneath that is metal carbonate and acid, gives salt, water and carbon dioxide. You have to remember that the test for carboxylic acids is fizzing with sodium hydrogen carbonate. That's a normal test, or even sodium carbonate would do. So metal carbonate and acid, salt, water and carbon dioxide. Carbon dioxide coming off, that is the fizzing there. Okay. So just a couple of examples, and the thing you've got to watch out for really is when you're using ions that have more than one charge. For example, magnesium, when it goes over to here, the magnesium in here is going to have a 2+ charge. The carboxylate, in this case it's the ethanoate, is only going to have a 1- charge, which is why it's in brackets and we need 2 of them. And then you have to balance it. So because I've got 2 down here, I'm going to need the 2 acids there. And again, I make hydrogen. It is, in all intents and purposes, exactly the same as the metal and acid examples that we did right at the start of the course. It's just remembering that the carboxylate part is the equivalent of the chlorine in hydrochloric acid, for example. So a few questions for you to have a go at.